Welcome to Cracking the Method, the scientific method. Up to this point in the art of observing the world around you, we've been focusing on solving problems and communicating in a very informal way. But in science, uh, it's more systematic and organized, and we use something called the scientific method, which is what you normally do. It's just a little bit more formal. The scientific method we generally think of as being a question followed by a hypothesis, test, gather some data, and answer our question. But it's not the only way that we can do it. We can do it in all forms and shapes of the way. We're going to sort of focus on those parts of the scientific method in the way that we normally think of it, which is to start with a question, which is what you want to know. Then you come up with an educated guess, a hypothesis, and we usually state it as, if we do this, then this will happen. Doesn't have to be all the time, though, of course. Once you have your guess as to what the answer is, you need to develop a very specific and repeatable experiment, how we're going to test the idea. We'll collect data, and then we'll analyze it and try to figure out whether our answer is right or not. That might lead to another question, or maybe a new idea for an experiment. Within the experiment, however, there's some very specific things that'll help us to prevent our bias or our opinion from coming in. So these are called the experimental variables and constants. These are very specific things that we are going to either change or keep the same. Variables, as it sort of sounds, are things that vary. That is, that they change or we change them within the experiment. The constants make up the most of the experiment, and those are all of the things that don't change. It's all of the things that we want to stay the same, because really what we're trying to do is to prove that something is causing something else. So the variables come in two flavors. They're not two different things, they're sort of different ways of looking at the way we're doing the experiment. The first thing is the independent variable. It is what we are experimenting with, and we only want one of those. The second thing is how that changes after we do our test, and we call that the dependent variable, and we usually measure that. So that's our measured variable. So you can think of it as the experiment and the result. And it changes depending, how this one changes depends on the experiment that we pick. Now in the textbook, on page 197 in the student handbook, there's a little section here on identifying and manipulating variables and controls. And really what we want to look at here is, in any experiment, it is important to keep everything the same except for what you are testing. Okay, so first thing there are our constants. The next thing that it says is one factor that you do change is called the independent or experimental variable. The factor that changes because of the factor that changes as a result of the independent variable is the dependent variable. So those are the three, and you can review that again on page 197 like we did in class. So let's take a couple of the examples that we had started with. We have three students, Juan, Jody, and Jim, and they're all sixth graders like you. And they love to play tennis, and they decide that they're going to come up with a team, and in order to be on that team, they want to test the tennis balls. They figure if they can serve super fast, then they're going to be on the team. So the question they ask is, which brand of tennis balls helps to produce the fastest serve? So which balls are the fastest? Okay. And it says here, before completing the experiment, they all think, there's our key word, that brand X tennis balls will bounce highest because they are all the hardest to squeeze. So they didn't just guess, they guessed based on some observation. So they think brand X. So let's see, go to squeeze. Using brand XYZ tennis balls, they decide to drop each ball from 15 meters above the ground onto a clay tennis court. They measure the height of each ball, bounces, record the value. They complete 5 trials. So they take XYZ, they drop them down 15 meters, they hit a clay court, and they bounce back up a certain distance. The distance that they go up is recorded in 5 trials in their data tables. So to me, the things that are kept constant would be the height, the court, and the tries. There are other things in here as well, but those are the 3 that most stick out to me. Now the variables are things that are changed. So one thing right off the bat is that we didn't use the same kind. We used X, Y, and Z tennis balls. And the other thing that changed is the height that it bounced up. Now, the thing that we're experimenting with, the independent or the experimental, would be the type of ball. Because that's what we are trying to find out about. The measured or the dependent variable is what we measured is how far they bounce. And so those are our questions: independent variable, dependent variable, hypothesis, constants. And of course, we need to know what the question is. So let's go to the next one. And this is the one that we will try next. We got some new 6th graders, Albert, Megan, and Tom, trying to grow the largest pumpkin for the state fair. So they want to know which type of soil. So the question right there is, which type of soil should we use? They determine which type of soil will win. Before completing the test, they all, there we go, there's our word again, think that potting soil will work. So there, how about this? Potting soil. Because it's going to hold water, and again, they didn't just guess, they came up with a good reason, an educated guess. They plant the pumpkin seeds in regular dirt dug from behind the school, sandy soil found at Megan's house, and store-bought potting soil. They fill 3 clay pots with the regular soil, okay, behind the school. They fill 3 clay pots with sandy soil here, and they fill 3 clay pots with potting soil. They plant the same species of pumpkin seed, water them with the same amount of water, and place them in the same greenhouse so they all get the same amount of sunlight. After the pumpkins grow, they measure how much, there we go, there's that key word, measure. Measure how much each pumpkin weighs and decide which type of soil is the best. So the constants are pretty simple. The same type of seed, the same water, the same sun, the same place. We'll give 4, we only needed 3. The variables, what were we experimenting on? We were experimenting on the type of soil. And what was going to change depending on the type of soil? Well, that was the weight of the pumpkin. Yeah. And again, we've got our independent, our dependent, our hypothesis, and at least 3 constants in our question. Lastly, one for you. Tim, Tommy, and Tina wanted to play in the garden. And at this point, I think what you should do is pause this, take a look at it, read it over, see if you can identify the question, the hypothesis, 3 constants, the independent and the dependent variable. Good luck, and I will see you next class.